Hello everyone and welcome back to TalentSprint series on Java Collections Framework. So we started this series with the idea of bringing to you collections in bit-size formats. So many of you requested to do a session on collections, be it queues, be it sets, be it a linked list or array list. There were plenty of requests, so we decided to come up with this 7-day webinar at 7 p.m. daily to address all the questions around the Java Collections framework. So far we have discussed list, set, and in today's session we are going to talk about queues. Now today is the third last session. We'll talk about maps tomorrow, and then the final session we would address iterators. Alright, so that is the plan. That would be the final session. Maybe we'll come up with more videos around the same, bringing to you questions or bringing to you some doubts that you would have raised meanwhile on the videos. But for now, this is the third last session that is on queues, and we'll close off the session day after tomorrow with iterator. So if you have missed out on the previous sessions, don't worry, you can continue from today onwards. You can join us in today's session and continue on for the remaining 2 days to kind of get back in the loop, and then you can go back and watch the previous videos that we have so far done. All right, so before I start, let me quickly say hi to all those who have joined us so far. We have Tejaswini, Secret Lucky, we have Madhav Rapu, all of those guys. I think you were worried about that the video is not coming. We just started, so don't worry, you haven't missed anything at all. Karan and Rahul are there. Hi Karan, hi Rahul, hi Mohit, Amir is there, Anil Kumar is there, Rakesh, Tech Guy, Tech Curry, I guess. Yeah, I think now you should be able to see the video because we have just started. Hi Bhargav. And on Facebook we have Prasad Verma, we have Manish Kumar, we have Nivedita just joined, Nagesh has joined, Amit is watching. So hello everyone, let's move on to the session for the day, and like I do every day, let's just quickly take a recap of what we have seen so far for those of you who might have joined us today only in the series, and even if you have joined continuously, been there with us throughout the series on Java Collection Framework. Let's do a quick recap. Let's brush up whatever we have seen so far and then jump on to queues quickly. All right, so far we saw what collections are, java.util.collections framework, right? And the main class, the root class that there is java.util.collection. Okay, now the collection class, the interface, has certain methods, all of which are public and abstract. All right, moving on, there is a collections class as well, which is a utility class which provides you with certain functions that help operate with these collection interfaces and classes, right? Further on, we saw synchronized versus concurrent collections. We then moved on to list, saw the different functions that are implemented by list, followed by array list and linked list. The next session we took a look at vector and functions again implemented by vector, followed by stack. Then we moved on to set. All right, the set is another interface that is part of the collection interface, collection framework. And then we looked at the implementations of set, that is enum set, hash set, linked hash set, tree set. All right, and finally we took a look at sorted set and navigable set. So this is what we have seen so far. All right, now moving on to queues, and before I jump on, let me quickly take a look at the chat. Manisha Rani says, I'm new to this. Manisha, you don't have to worry if you are new to this. Just consider today's session as a session on queue, and if you are even new to Java, then this might be a bit difficult. But if you have an understanding of data structures, still this is easy to comprehend, because queues are underlying, you are using data structures, right? So it will tell you how Java is using those data structures, providing you a framework, that is Java collections framework, to deal with data in the basis of these structures provided, right? And later on you can go back to the previous videos that would be there on Facebook as well as on YouTube. So wherever you are watching this session, I think you are watching it on YouTube right now, yeah. So you can go back to the YouTube channel, watch the previous videos to get a hang of what we have discussed so far, all right? But this has no connection to what has been done so far. Consider this as a unique session on queue, all right? Okay, Bollywood short mix-up, Nitish Kumar, Bhargav Kumar. Hello everyone. Let's quickly jump onto queues. Now, as you see on the screen, there are 2 points written about queues. One, that is a queue is a ordered list of objects, and second is FIFO. Now, those of you who are aware of what FIFO is, you would know that it is first in, first out. Now, unlike stack, that is last in, first out, queue is a first in, first out structure. But before I go into that, what is actually a queue? So the literal meaning, if you see, of the word queue is a waiting line. Okay? If you are standing in the line to get petrol filled in your cars or bikes, if you are standing in the line of a restaurant to order your food, that is a waiting line. So what happens in all these waiting lines is the person who enters first in the line is the person who gets served first with the order. Correct? And he is the person to exit first out of the line. Now behind this, if there is another person number 2, he'll get his order next, and so on. So the person who joins first is the person who gets out of the queue first. Similarly, the person who joins last will be the person who gets out of the queue last. The same implementation in Java is done using a queue. Okay? So in queue, what happens is elements are entered from the rear end, that is called tail. So O1 will enter here. Correct? Now in next, if you want to add one more element, O2, O1 will come here, O2 will enter after this. Again, let's say third element, O1, O2, O3. And like this, we will keep filling the queue with one after the other. So the fourth element will come after the third, and so on. So this is from where we keep entering the elements. Now, if you have to take out elements from a queue, we have seen here in this example that the person who goes in first in a queue is the person who gets out first. So if you have to remove something, that is done from the head of the queue. Alright, so if you call remove on your queue, the element that would be removed is O1. So if you do remove, O1 will be removed, you will be left with O2, O3, O4 and O5, and the head will now be pointing to O2. Now again, if you do another remove operation, O2 will be removed this time, and the head will point to O3, and so on. Now let's say head is pointing to O3, we have removed O2. Now we enter one more element, again that will come after the last element that was there. Okay, O6, head would still be pointing to O3, the topmost element, and elements will enter through the tail. Okay, so I hope this basic implementation of how a queue works, the real life scenario, and mapping it to the Java scenario is so far clear to all of you. Let me see if you have any doubts. Bhargav says, ma'am, I'm also new to this. Bhargav, that's okay if you are new to this. It's just a basic queue session. Walk through the session with me, and then you can go back and watch the archive to take a look at list and set. Okay. Shirang is asking how to crack aptitude. Shirang, there are aptitude sessions on our channel, on aptitude bank channel. So you can go back to the TalentSprint page, IT page, and you will find a link to the bank channel in there. So you can click on the link and watch all sorts of interesting videos that are done by Rohit Agarwal, where all he teaches you is how to be masters in aptitude. So that problem, if you have, will be taken care of by Rohit. Priyanka is saying, how does design patterns work on Java? Priyanka, design patterns, I think Madhav Rapu has already asked me to take a session on MVC, and now you're asking design patterns. So maybe the next live class, the Monday live class that I take, I will do it on design patterns and MVC architecture. So let's keep this for that, and let's limit our session today to Q. Nitish says, I am having great difficulty in understanding this. Nitish, it's just simulate this with a real life example, right? The line of a grocery store, or the line of a food store, or the line of a petrol pump, right? The person who is entering before you is the person who will get out of the line before you. Similarly, in queues, the element that you enter first is the element that gets out first. Now, to represent which element is entering from where, we say that the addition is taking place at the tail end and the removing is taking place at the front end, like any other queue. So in this restaurant queue, let's say this is a restaurant simulation we are doing, okay, we can say that this is the tail end where people come and keep joining, right? And this is the head end. So if O1 takes his order and goes out, next in line will be O2. So head will be pointing to O2, correct? Similarly is the case with our queue implementation in Java that we have seen here. Okay? Dharmendra, you are not late so far. You can catch up with the session. You can also say last in, last out. You can also say that, but the thing is that the operations are performed. That is, if you want to remove the element, you will be removing it from the head. So with respect to that, it is said first in, first out. Similarly, in a stack, right, the removal takes place on the last element. So it is called last in, first out, a stack. So I guess the name is, the nomenclature is given based on the removal ideology. But in other way, it's true to say that whatever goes last will come out last. So last in, last out current is also pretty okay. Most frequently asked questions from C programming. Anil, we have a playlist on our channel on most frequently asked programming interview questions. So you can go ahead and take a look at that. It's a mix of both Java and C programming questions. All right. And you can go to both of them, and also the live sessions that we took, I think 2 sessions or 3 live sessions before, there was a session where we solved some most frequently asked C programming questions, if I'm not mistaken. So you can go ahead and take a look at that too. But the frequently asked programming questions playlist definitely on YouTube has certain questions that can help you. Alright, Kanika is asking when to use queue and when to use a stack. Okay, and Dinesh is asked underlying data structure of queue. Okay, so underlying data structure of queue is this. This is how you represent the underlying data structure of queue. Last in, first out, if you have to show it pictorially representing, right? And which cases we use queue and which cases we use stack. The simple explanation is, the prime feature of a queue is this, that it allows you operation on this first element. So any structure where you want to operate on the first element, the element that is at the head of the queue, you would use a queue collection. Whereas you'll use a stack when you want to operate on the last element that is added to your stack. Okay, that is added to your collection. That is the difference. So here you operate on the first element that was added, whereas in stack you operate on the last element that was added. All right, that's essentially the difference between queue and stack. Dharmendra says, I don't know the implementation of data structures in C and C++, but I know it in Java. Should I add data structures to my resume? Yes, of course you should add data structures to your resume. It doesn't matter whether you know it in C or in C++ or in Java. If you know data structures, it's a subject in itself. So if you know it in any language, you can definitely go ahead and put it in your resume. All right. Okay. So Madhav Rapu is asking where it will be useful in real time, ma'am. So like I said, real time scenarios like queue simulations, like a restaurant queue or a grocery store queue or a petrol pump queue. If not an actual queue, any situation where you have to work on the first element of your data structure, right? All those are the cases where you go for so this is the first element at this point of time. Right here, this is the first element. Okay, if this is also removed, then O3 becomes the first element. Okay, so wherever you have to work with this first element that is added, that order you want to maintain and you want to work on the first element added, you use a queue. Okay, now a few more properties of queue are: queues allow duplicate elements to be entered in the collection, but they do not allow any null element to be entered. If you try to enter a null element into a queue, it will give you an error. All right, now let's move on to the functions that are provided by the interfaces for us to work with collections. All right, now what interesting is about these functions is that so far we have seen that add remove operations are simply performed by one element each. Like there would be a add function, there would be a remove function, or there would be a peek function to just check the element like we saw in stack yesterday. Okay, but in a queue we have two operations for each, correct? So insertion, we have two operations, add and offer. Retrieve, we have two operations, element and peek. And remove, we have two operations, remove and poll. Now why do we have two methods to do one task? Like why do we have add and offer to perform an insert operation on a queue? One should be sufficient, right? The difference is that if any error occurs, okay, the first list that you are seeing, that is this first column, this will throw an exception if any error occurs while performing these operations. Whereas this list right here, instead of throwing exception, it will return a special value that will tell you whether the operation that you wanted to perform was successful or not. Instead of throwing an exception and stopping the program midway, these operations right here will return a value telling you that the operation was performed successfully or not. Okay, so let's quickly take a look at all these functions, what these functions do, right? Now insert, that is performed by add or offer. Now if you insert a normal value in the queue using add, it will add the value, but if you do the same using offer, it would return true if the insertion was successful and false if the insertion was not successful. In case of add, if the insertion is not successful, it will throw error. Okay, similarly for retrieving, that is retrieving the value, the first value that is there at the head. Retrieve always gives you the value that is at the head of the queue. Okay, so for retrieval, when you want to check the value at the head of the queue, you can use either element or peek. Now similarly, since these are the functions that return a special value, peek returns, let's say if there's some element present, so it will return the element that is at the head position, if let's say the queue is empty, so peek will not be able to return you any element, right? It will return you null if the queue is empty. In this case, if you use element, if the queue is empty, again it will throw error that the queue is empty. There's nothing in the queue for me to return back to you. Okay, now again, if you have remove, okay, if you have to remove your data, now removal again takes place from the head of the queue. Okay, so let's say this is your queue with certain data inside. This is the head and this is the tail pointer, right? Now when you want to remove the first element that is there, let's say object 1, this element is going to be removed. So similarly, remove operation does the normal removal, but if you call poll will again remove the head element from your queue, but similarly, like in the previous cases, it returns null if the queue is empty. If the queue is empty, there is no element, that means there is nothing for the poll function to remove from the queue, right? So it will return you null. Okay, so if you guys have any doubts so far, let me just quickly go back and check. I'm getting a lot of comments from you. I hope you guys are clear with whatever we have discussed so far. So someone was asking where in real life we are going to use queue. Ashokan has given a very nice example that whenever OS operating system of your computers are performing their task, those tasks in the operating system are also queued. So multiple tasks are not running at the same time, right? They are getting their own duration to use the operating system. So let's say there are 3-4 tasks, task 1, task 2, task 3. This gets 4 seconds, maybe this gets 10 seconds, and then this gets 3 seconds again, and then again you come back to the 4 seconds of first. So these tasks again are also the basic working of OS. When multiple tasks are being taken care of by the OS, these tasks are also queued in the same way that we have seen so far. Is the size of the queue fixed like array? That is, we have to define the size first before using it. The size of the queue is not, see, the point of using collections framework, like I said in the very beginning, the first session when we discussed collection interface was that they expand or get back to the size if you delete more elements on their own. You don't have to worry about the expansion of size, how it is happening, where it is happening. When you call add, if the queue currently whatever size it is full, the add function will internally call another function, that is ensure capacity, to increase the size of it. So you don't, and there are logic behind increasing size, like we saw before. Some collections increase to double the size if you add the next element that goes out of range, or some collection increase to half the size that they were. So that logic is taken care of. When to use element, when to use peek. I would suggest you should always go for offer, peek or poll instead of add, element or remove, because nobody likes a stupid exception thrown in the program. If you are getting a special value that is telling you what has happened or what has not happened, giving you true, false, giving you null, giving you values that you can take and see whether the function that you actually wanted to perform has worked right or not, right? So you go ahead and use offer, peek and poll, correct? Bhagyodaya is asking to repeat peek. Bhagyodaya, peek will give you a, like the name suggests, it will give you a peek it will give you a sight of what is this first element that is present at the head of the queue. Similarly, element will do the same. It will give you what is the element at the head of the queue. It's just that if the queue is empty, this one throws error, this one gives you null, that the queue is empty. Okay, one more point Ashokan has mentioned is that there are two levels of skills. Number one is knowing how and when to use these data structures. So that you can decide based on all the properties that you get to know about these data structures, like which allows you to have null values, which allows you to access or insert or delete order elements in what order, right? Based on these properties, you know how and when to use the data structures. And the second is knowing how to implement them. So if you have to implement a queue, in what way you would want to implement a queue? So there are several ways that we'll take a look at. Like yesterday we saw, let me go back to the sheet. Yesterday we saw different implementations of set, right? We can have enum set, we can have hash set, we can have linked hash set, we can have tree set. So depending on what our requirement is, okay, we can decide between these implementations which one we want to implement. Okay, so these are the two things. One, you need to be aware of the how and when to use the data structures, and two, you need to be aware of the implementations. Okay, like these classes that implement set properties or the classes that implement queue properties. Okay, so talking of implementations, the queue implementations are basic linked list and priority queue. Now what a linked list does is it provides you with a combination of list plus queue. Okay, so you get a combination of both of these characteristics into a linked list queue implementation. So where would you use a linked list queue implementation? When you want fast adding and removing of data, right? Because queue allows fast adding and removing of data, since they are adding data only at the header, removing data only from the header. And second thing is when you want, since it is implementing the list interface as well, so when you want faster accessing of elements, when you want a combination of these two characteristics in your program, you would go for a queue implementation, that is a linked list implementation. Now the simple code for the same is this. You created an object QA that is calling new linked list. Similarly, QB is a priority queue, right? And this is the code. Now where do you use priority queue? What priority queue do are, they are natural ordering queues, where the ordering in a priority queue is defined by the comparator that they implement, or let's say the program requirement decides the ordering in a priority queue. All right, again, the one advantage is fast adding and removing of element from the header. Okay, now since priority queue does not use list interface, does not implement list interface, it won't have a faster accessing of element. When you want in your program that the accessing of elements also should be faster, you should go for the linked list implementation of queue. All right, jumping on to DQ. What is a DQ? DQ comes from your java.util.dq interface. Remember, whenever I am writing, like I said before, whenever I am writing these in the slides here, this is an interface. Okay, now what is a DQ? DQ is a doubly ended queue, which simply means that it is a queue where both addition of data and removal of data can be performed at both the ends. Alright. So you can add and remove data from the header side as well as from the tail side. So far what was happening is head was removing and tail was adding. Now in a DQ, when you want to implement certain programs or characteristics where you want the addition and removal to be happening from both the ends, you would use a DQ. Now DQ implementation, again there's linked list implementation which works exactly like before, but this time it would be working from both the ends. And then there is array DQ. Now what is array DQ is simply put, it's a array implementation of DQ. So this is a simple array where you add data here, remove data from here, or if you want to work at the head, add data at the head or remove data at the head. So this uses array as underlying structure and this uses a linked list as underlying structure, but they both operate as queue. Okay. Now before I move on to the final function slide that I have for DQ, let me see if you guys have, okay, element and peak. I hope those of you have asked me for element and peak, it's clear to you now. If it is still not, let me know, I'll repeat it once again. Okay, for Maheshri, I'll repeat this. What is happening here is, if let's say you want to add or let's say you want to remove an element from a queue, okay, but the element can be removed only if there is a, what if the queue is empty? What will remove do? It will not find any element to remove, right? So it will throw an exception or give you an error. Whereas poll, if you call poll instead of remove for removing the element, it will return null, telling you that, by which you will understand that if the poll is returning null, that means my queue is empty. There is no element in my queue. So this makes understanding what is actually happening in the queue a bit more easier and faster. Alright. Can we retrieve any middle element in queue rather than element present at the head? Kanika, the whole point of using a queue as a collection in the program is that you don't want to work or you don't want to tamper with the data that is present in the middle of the queue. Similarly is the case with the stack. You don't want to tamper, you have to implement a situation where only the element that was entered first or the element that is present at the head is the element that is worked upon or deleted upon or removed, right? So that is why you will use queue, and queues don't allow to fiddle with the middle element, okay? Okay, Dinesh Singh is saying, could not understand poll, please repeat once again. I think Dinesh, now this is clear, should be clear to you. How to find, someone has asked me how to find size of a queue. So to do all the basic operations like how to find size, how to check if the queue or the list or the stack contains some element or the not, these basic operations are provided to us by collection interface already, right? Let me quickly go back. You see, we have basic operation like to check if our collection contains some object or not, to get the size, to convert our collection to an array. You know, basic operations are already provided to us by collection. Now the subset of collection is queue that we are discussing today. We have already seen list and we have already seen set. Alright, and now we are taking a look at queue. Now in queue we have linked list implementation of queue, we have array DQ, correct? We have priority queue. These are the different implementations of queue. So all these implementations would by default have all the functions that are provided to us by collections. Since we are using collections interface, these are the subclasses of collections interface, right? So size, checking whether some element is present or not, etc. Those all functionalities, Karan, are already present in the collection interface and they will be used. Okay, cool. So moving further, like we discussed, that DQ, addition and removal, is possible from both the ends, okay, from head as well as the tail. Now since it is double-sided, the operations also become double-sided. So we have add first to add element at the first. Let's say this is the Q. Okay, now add first will add element here at the first place. Add last would add element at the last. Okay, let's say this is the first, this is the last. That is, this is the head side, this is the tail side. Okay, similarly we have offer first and offer last. So again, offer is, like we discussed, another form of insertion, right? Add is one form of insertion, offer is another form of insertion. So offer also becomes two-way, offer first and offer last, that would add at the last. Similarly, remove first will remove element from the head side, remove last will remove elements from the tail side. So if you call remove last, this element will be removed. If you call remove first, this element will be removed. Okay, then we have pole first and pole last. Again, ideas of pole is that you remove the element, another version of remove only. And similarly we have element first, that will give you what is the value at the first. Element last will give you what is the value at last, that is this side. Then we have peak first and peak last. So far in a simple queue we had 6 functions, right? Add, offer, element, peak, remove and pole, which were doing 3 type of operations. Now we have here in a DQ we have 12 functions that are doing again 3 type of operations, but from both the ends, so from front as well as back. All right, those are the DQ functions, correct? Now let me quickly check what doubt you guys have. Okay, DQ once again. Mother Apu Sai has asked, can you explain DQ once again? DQ, like the name says, break the name D and Q. So that is D for doubly, E for ended and Q. So DQ is a doubly ended queue. Now in a normal queue that you have, insertion happens from the tail end and deletion happens from the head end, right? So let's say this is your queue right here. If you want to add one more element, it will come back here. One more will come back after this, one more will come back after this. Now same queue, when you want to remove element, the first head element will be removed. Okay, so this element goes out, then head points to the next, this element goes out, then head points to the next. So this way, like a simple queue keeps moving, our queue collection also keeps moving. But in a doubly ended queue, this operation is performed both ways. So you can add element from this side as well as from this side. It is not just one-sided now. Instead of keeping adding elements from the tail end, you can add elements from the head end as well. Okay, and similarly when you are performing removal, right, you can remove elements from the tail end as well, just instead of removing elements from the head end. So it can grow in both sides, it can shrink in size from both the sides. since from both sides now you are able to perform addition and deletion of operations. That is doubly ended queue. All right. Okay, array DQ is nothing but a doubly ended queue, and a linked list DQ is also a doubly ended queue, but linked list DQ uses linked list as its base to create a queue, whereas array DQ uses a array as its base to create a doubly ended queue. So at the base you still have to have a data structure, right, to give these functionalities on top. So linked list DQ would use linked list, whereas array DQ would use array as the base to create this DQ collection. Okay. Aminul, good evening. You are pretty late to the session, I guess. You'll have to watch it again. Okay, Dharmendra is saying, I'm confused with making object of some interface and initializing it with some another class, like DQA is equals to new linked list. See, DQ is an interface. Now you cannot create an object from an interface, right? If you want to create an object from that would implement the functionality of a DQ, you need to have a class that implements this interface. You cannot say DQA is equals to new DQ. That will not help. You cannot create an object from an interface. So linked list or array DQ is an implementation of the interface. So whenever you want to create a DQ, you want to implement this interface, you either use a linked list DQ or use a array DQ, right? That is why the initialization and declaration of these objects are like the example that you have pinged me, Dharmendra. All right, what next? Madhav Rapu, your question is answered. Difference between methods and functions. All right, so that's it for the session on queue, guys. I'll see you tomorrow with another session on collections framework where we'll talk about maps. Now maps, as you would see in the structure hierarchy, if you see that collection interface would have list, set and queue. So map is not essentially part of the collection interface, but whenever you talk about the collection framework as a whole, you also talk about maps because they also provide the similar kind of functionalities of accessing data, inserting data in a certain way, sorting data in a certain way. We'll discuss more about the same tomorrow. Why do we have maps? Why do we discuss them as part of the collection framework, etc. And then the final session, that is day after tomorrow, we'll talk about iterators. All right, so don't forget to join me and don't forget to subscribe because there are more interesting videos and playlists coming out on the channel for you guys. I'll see you tomorrow at the same time, 7 p.m. Stay tuned for the session, and until then, have a nice day and keep coding. Bye bye.